In this question, we have 3.24 grams of sulfur, but we don't know how many atoms of sulfur we're talking about. And 40 grams of benzene, we know that the boiling point, right? It's above by 0.81 of pure benzene, so that's delta T. And that's K, just to give it a constant. So I'm thinking, well, it's colligative properties, I, K, M. And in this, we've got delta T, I'll plug that in a second. I, since it's not an ionic compound, we just got sulfur, it's a molecular compound, this is organic, this is just one. And really, I would have to do with sulfur, not benzene. K, we got that. M, we don't know. And typically, when you have a question that asks you for, say, a mass, say it asks you for a molar mass, or even this, the molecule, things like that, that's in molality. So lowercase m. So we plug this in, and we say 0.81 equals 1 times K, 2.53, times molality. And my first step would be to find molality. Does anybody have that number? No? Okay. We will calculate it, just so we can progress in the problem a little bit.
0.32.
Oh, perfect. 0.32?
Yeah.
Okay. Now we need to remember what's molality. That's the moles of the solute, that's the sulfur compound, over the kilograms of the solvent, that's the benzene. Okay? So, the kilograms of benzene, well, we know it's 40 grams, so just to change that to kilograms, 0.040 kilograms of benzene. That'll give me the moles of sulfur, okay? So, if wonderful person who did the previous calculation find this, that'd be fantastic. 0.040 times 0.32.
0.00128.
Excellent. Okay, this is moles. Now, I'm trying to figure out how many sulfurs are in there, so if I found molar mass, that would actually be helpful. So I'll go over here, let's go to a different color. The molar mass of the sulfur compound is grams per mole. And I have grams. It's 3.24 grams. And I have the moles. It's 0.00128 moles. Okay, I'm ready. What would this number be? And then you'll need, at this point, your periodic table to find the molar mass of sulfur.
2531.25. 2531.
2,531? Whoa.
Or divide 3.24 divided by 0.00128.
Uh-huh.
Yeah, it's 2531.25.
Well, we need to double check the math. That's crazy. Guess it could be, but
0.32 0.04 is only 0.0128.
oh, get rid of that. Get rid of that. Move the decimal point over 1. Beautiful. Okay. Now I think the molar mass of sulfur is like 32. Does that sound right?
Yes.
So this is sulfur X. I know one sulfur, I think it's 32.07. What's that number? I think it's 8.
So you grams per mole, but couldn't we just look up molar mass? Like I don't see where the unknown is in the molar mass equals grams per mole.
How else would you have found this number, 253?
isn't molar mass just what's on the periodic table?
Yes, but we don't know how many sulfurs are here.
Okay,
That's the problem.
got it.
So if we knew there was 8, yeah, we can find that 253 pretty easily.
Okay,
Okay, that was the hard way to do the problem. The easy way to do the problem would be, remember, where is it? It's in, I think it's in the 2B binder 2, but it's definitely in the 2A binder. Go to page 15. It gives you kind of standard conditions, and sulfur, the most common form of sulfur is sulfur 8. So I would pick that. The phosphorus, phosphor 4, any of the diatomics, I would pick the 2. You know what I mean?
yeah.
So had you remembered, oh, sulfur's typically 8, maybe I will circle that answer and come back to it if I have time. You would have been really good.